This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Get to know Proximity Malt. We malt superior, European-style, low-protein varieties grown close to home in Delaware and Colorado. Domestically grown, precisely malted to style. With our team of seasoned experts and 2 brand-new malt houses, try what's really new in malt. Check us out at www.proximitymalt.com.
Additional support provided by
The secret to quality fermentation is White Labs. Core strains are made weekly and most can ship out the next day. Order through the White Labs app or yeastman.com. Visit whitelabs.com/whywhitelabs for a new customer special offer. That's whitelabs.com/WHY Whitelabs.
When you talk about $1 per 4-channel reaction versus the cost of these kits, you really want to make sure you have that open instrument now so that when these open PCR systems do start really coming online, you're able to take advantage of that.
This week on the show is PCR Right for your brewery. Kevin McCabe talks about how PCR works, how he uses it at full sail, the different types of instruments available, and more. Kevin, there's got to be some brewers listening out there who have no idea what this technology does or how it could help them in the brewery. Give us the 30,000-foot overview of PCR.
So PCR is a method that makes exponential copies of a specific target DNA sequence in your sample. It's very specific, but it's very sensitive and very powerful if used the right way.
So PCR is essentially telling you whether or not the specific DNA that you're looking for is in the sample, right?
Yeah, exactly.
Okay, without going too far down the rabbit hole, what are the basic steps that occur inside the instrument?
So the neat thing about PCR is that it's really just a manipulation of temperatures. It starts out really hot, which takes the double strand of DNA and separates them, exposing the hydrogen bonds on the inside that make the DNA pair. What that also does is it frees up those bonds to allow for your primers to come in. And your primers are what specifies the DNA sequence that you're going to target. So as you cool down to an intermediate temperature, those primers come in and anneal to the double-stranded DNA. And then the polymerase, the enzyme that copies the DNA, comes in and will make the DNA copies based off of those primers. And as you repeat this stepwise a few times, you get an exponential increase where 1 copy of DNA becomes 2, then 4, then 8, and 16, and so on.
Okay, you just mentioned polymerase, but we never really defined what PCR stands for, so we should probably do that.
Okay. PCR stands for polymerase chain reaction, and polymerase is the enzyme that copies the DNA.
All right, very good. Now, there are several different types of PCR. We hear terms like endpoint, real-time, qPCR, etc. Which type is most common for brewery applications and why?
So, which one's most common? I would venture a guess that quantitative PCR is becoming more and more common. But I know there are some systems out there that still use endpoint PCR with some sort of add-on analysis to make an estimate of quantitation of the DNA that's being copied in the reaction. Quantitative PCR is great because it uses a fluorescent signal that the instrument itself can read. So you don't need additional downstream equipment for a readout of the PCR the way you do with endpoint.
Talk about how you've integrated PCR into everyday QC procedures in the brewery.
So this is kind of a funny question because when I started at Full Sail with a molecular biology background, I thought, I can bring this technology in and really leverage it to improve upon our quality program. And it turned out that I didn't bring it in for 3 years. I didn't bring it in until we started working with a kombucha product, our Kyla Hard kombucha in the brewery. Because PCR is great when you're looking for specific things. In our case, we're looking for the microbes that we know are present in our kombucha product. But it's not very good at monitoring plant sanitation, which is what the rest of our already established microbiological quality control program is based upon. We do a lot of plating at various points in process to see not just whether there are spoilers there, but whether our CIP or COP processes are working well. Make sure things aren't changing over time more than we're necessarily looking for spoilers. And so PCR was really leveraged specifically around the introduction of these kombucha microbes into the plant.
Okay, so I just want to underscore PCR, really not a good choice if you just want to know if anything's growing in your beer. You've really got to be looking for something specific.
Exactly. A lot of the systems that are out there for PCR, the kits that are available to a lot of the brewers, are really focused on looking for lactobacillus, hops resistance genes, wild yeast, things like that. They're not really focused on plant sanitation monitoring. They're going to tell you if somebody bad is there, but they're not going to tell you if there's this change in the plant microbiology that you might see when certain processes aren't working quite right.
Since you've introduced PCR, like you said, the original intent was to monitor cross-contamination with kombucha microbes, but are you using it in any other ways at Full Sail now that you have it?
Yeah, I mean, the nice thing is I have a background in the bioinformatics that underlies PCR, basically manipulating and aligning DNA sequences to design PCR assays that we want. And that's allowed me to leverage this for different uses. We can look for the presence or absence of yeast. I've designed our own primers for hops resistance. The way I've set up our system is I look for the presence or absence of Lactobacillus and Acetobacter, the key microbes in kombucha. And if I get a hit on the Lactobacillus, I'll then go back and do a secondary PCR for hops resistance. Theoretically, I could integrate it into the same reaction, but I just don't want to waste reagents because we hardly ever see that hops resistance gene pop up in the plant.
Do you ever run PCR on third-party yeast? And if so, what are you looking for?
So we do all of our yeast propagation in-house. However, should we bring in yeast from the outside, I do have some primer and probe sets for Diastaticus, and I would definitely be checking for that if we were bringing in any third-party yeast.
I have a feeling the answer is no, but has PCR replaced any traditional QC methods at Full Sail?
For us, the answer is no. We really rely heavily upon that plant sanitation monitoring approach in our QC program. So PCR has been an add-on, but it hasn't replaced any of our traditional culture.
You think that's pretty much the case elsewhere in the industry, or are you hearing of other maybe smaller breweries that didn't have that established plating program up front and they come in with PCR out of the gate?
Yeah, I mean, I'm seeing more and more breweries bringing on PCR with or without an established program. My advice would really be know what the assay is telling you. Because if you don't understand how PCR operates or what your plating methods are, what media you're using, how selective it is, things like that, you don't get a picture for what's really happening in the brewery. And you really have to take that big picture view. Okay, this test tells me X, Y, and Z. This other test tells me A, B, and C. And I need to know K, L, and M. I'm not getting the information I need. It's pay attention to what the tests are telling you and make sure you're getting the answer that you want when you use them.
Coming up.
So there ends up being this return on your investment for spending more for a 4-channel quantitative PCR system versus endpoint or a single or dual channel instrument.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Support for this podcast is brought to you by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
additional support provided by
Bring the world to your brewhouse with BSG's diverse selection of ingredients and services. Our dedicated customer service team and industry experience provides you with the assistance you need every step of the way. Make BSG your supplier of choice with products essential to making great artisanal beverages so you can stay focused on your craft. Visit us at bsgcraftbrewing.com or contact us at 1-800-374-2739.
Here's what's coming up on the Master Brewers calendar. District Midwest meets at Wolf's Ridge Brewing in Columbus, June 29th. Don't miss the July 10th safety webinar, Lockout Tagout, It's the Law. The District Michigan Summer Social is July 13th at Fitzgerald Park in Grand Ledge. District St. Paul, Minneapolis joins forces with the Minnesota Craft Brewers Guild once again for the Master Brewers Conference July 26th in Duluth. The District Texas Summer Meeting in Kerrville is the weekend of August 2nd. Master Brewers Brewery Systems Technology and Maintenance course starts August 18th in Madison. And the District Ontario Hop Field Day is August 24th at Good Lot Farmstead Brewing Company. It's time to start making plans for the 2019 Master Brewers Conference. If you can only make it to one conference in 2019, this should be it. We're really mixing things up this time and heading to the Calgary Convention Center to see how Alberta celebrates Halloween. Check out the full calendar of events at MBAA.com for more details or to find a district meeting near you. Now back to the show. Can you give us any examples of a time where PCR maybe really saved the day at Full Sail?
Fortunately, we haven't had a lot of cross-contamination events that you might expect while having, kombucha in a beer brewery. We've really paid attention to processes throughout the development of the kombucha product and a lot of CIP validation to make sure that our methods our cleaning methods are actually working. I'd say that's the most important thing that PCR has given us is the confidence to leverage the plant's capacity for this kombucha product and letting us sleep at night knowing that we're not messing up our beer.
That's important. You've already mentioned how common PCR targets are spoilers like lacto, PDO, wild yeast, diastaticus, things like that. But I'd like to hear about any unusual or unique PCR applications you've heard about from other folks in the industry.
I think when it comes to plant sanitation monitoring and quality control, those are really the main assays that people are using. There are some interesting kits out there that are using a multi-tiered approach to go after very specific, almost species level determinations, where initial amplifications are then followed up on with either additional amplifications or the use of sequence-specific probes to really drill down on who, as a microbe, is there. There's a lot of in the broader food safety industry, which is something that we don't really look at too much in breweries right now, but may have to look at in the future if there are any changes to FSMA, are pathogen detection. There's a lot of PCR-based pathogen detection. I did some early research on that in the 90s.
And that can be very important as brewers continue to push the boundaries of beer and make some very low alcohol or beers with different pHs and things like that, right?
Yeah, I think that, if FSMA does change with respect to brewers, it's going to be in response to some sort of food safety problem, unfortunately. I'm all for the creative aspect of brewing and coming up with novel approaches, but really keeping an eye on pH, alcohol, and hops as the three key protectors of beer as a product need to remain a major focus for everybody in the industry.
What are the most important things to consider when selecting a PCR system?
So, different systems have different approaches. Some of them use enrichment, which, can be helpful in certain circumstances, but also robs the user of one of the most powerful aspects of PCR, which is its speed. If you take 24 hours to enrich a sample, you're going to probably see turbidity in a liquid culture or colonies on a plate. You're not taking full advantage of being able to run PCR from start to finish in under 2 hours. The other things then, beyond whether you decide to enrich or not enrich, really comes down to the type of system you want to use, whether you're using an endpoint PCR where you then have to have some sort of assay for determining how much DNA is created, or whether you're using fluorescence-based quantitative PCR, where the instrument does both the amplification and quantitation at every cycle, so you can get a better estimate of the amount of starting DNA. I would really encourage people that are getting into this to look at the costs over time of the two methods, and look towards multi-channel, multiple color fluorescence quantitative PCR instruments, because when you have an instrument that has multiple color channels, you can run multiple assays in the same tube, and you're not redoubling the reagents that you use for every single specific target, and it ends up saving you money in the long run.
And probably time too, right?
Oh yeah, time too. I mean, every time you have to set up a reaction, you're sitting there with a micropipettor, and that's valuable as well.
Okay, so let's hear a bit more about instrument cost. Maybe give us some ranges, and let's also put some numbers to that cost per reaction.
When you're looking at single targets with a fluorescent cybergreen dye, it ends up running about 56 cents per reaction, whereas if you're using a sequence-specific probe, it's about 82 cents. The probes tend to be a little bit more expensive. But when you get into that 4 targets per tube, when you have to copy into 4 different tubes, if you're using Cyber Green to hit 4 different targets, you're up at about $2.25. Whereas with probe-based system, you're only adding about 19 cents, and it comes out at about $1 per 4 targets.
Okay, and how about ranges for instrument cost?
Yeah, instrument costs with an endpoint instrument, you can probably pick them up really cheap used. There's lots of instruments out there in the used equipment market because they're broadly being replaced with quantitative systems at this point, the qPCR that we've been talking about. But a new one will go for around $5,000, but you still need to be able to get the results out from that.
That's a new endpoint or a new qPCR?
A new endpoint PCR is probably going to be under $5,000. But again, you still need to get the results. You need either a kit, like some of them are like pregnancy test type kit that have a color change. You can use agarose gel electrophoresis with a DNA staining dye. There's lots of different ways to get the results out, but you have to, there's some sort of add-on with endpoint PCR to get your results. In terms of quantitative PCR, on the low end, there's some open source instruments from Chai that are around $4,300 to $6,000, whether you're looking at a single channel or a dual channel. When you get into the 4-channel instruments, mid-range is going to end up being about $14,000. High end, you can get up into like the $55,000 range for those. But again, there is going to be that reaction by reaction return on investment. The more channels you have, the more assays you can do in a single tube, and not having to have that endpoint secondary system to get your results out, whether that's the kits or the gels or whatever. So there ends up being this return on your investment for spending more for a 4-channel quantitative PCR system versus endpoint or a single or dual channel instrument.
There are now lots of commercially available kits. To what extent are kits from the various vendors comparable or interchangeable?
That's a really key consideration. Some kits are really locked down tight, and you can only use their tubes, their reagents, their system with that instrument. So you're making an investment on an instrument that you can't do your own work with, that you can't adapt for your own use. And I think that you have to really want to use that specific system if you're going to have some sort of proprietary lock on being able to use it. Other kits that use quantitative PCR use instruments, but the software is locked, where you can only run their programs. I really encourage people to look for open source instruments that you can end up designing your own primers and probes down the line. I think that's really going to become a reality here in the next year or two, where there's all this data out there around open source PCR systems in the scientific literature, and there's different people, including myself, working on developing them. I think in the next couple of years, you'll start to see those systems coming into place and being validated in the brewing community. And when you talk about $1 per 4-channel reaction versus the cost of these kits, you really want to make sure you have that open instrument now, so that when these open PCR systems do start really coming online, you're able to take advantage of that.
That's good advice. There are some kits that advertise differentiation of lactobacillus strains. How is that possible?
When you're separating or you're distinguishing between different species, it's based upon differences in their DNA sequences. And so that's more of an exclusive design. If you find regions of a gene or even different genes that one lacto bug might have that another doesn't, you can target those with the primers or the probes and identify those unique sequences and parse out which lacto bug or PDO bug you're actually seeing present in that sample.
That was Kevin McCabe here on the Master Brewers podcast. If you want to learn more about PCR, check out Kevin's webinar. I'll add a link in the show notes, or you can get there from the Education tab or by typing PCR into the industry's best search bar at MBAA.com. Are you enjoying the Master Brewers podcast? Let me tell you about a simple way you can help us keep making more. Take a minute to thank our sponsors. There's no way we could produce this show without generous support from sponsors like Hopsteiner, ABS, Proximity Malt, White Labs, and BSG. So please let them know you heard their message on the Master Brewers podcast and that you appreciate their support. It's time to start making plans for the 2019 Master Brewers Conference. If you can only make it to one conference in 2019, this should be it. We're really mixing things up this time and heading to the Calgary Convention Center to see how Alberta celebrates Halloween. You can find all the details on the Meetings tab at mbaa.com.
My fist full of courage, my heart full of rage. Well, I can't get stuck, I can't be losing too much, and then I'm heading out to any other place. My fist full of courage, my heart full of rage. Well, I can't get stuck, I can't be losing too much, and then I'm